like at the night, you sometimes see stars with a telescope, right? Like we can see some stars with our naked eye. Just wait. Just wait. Like if we see like some stars, you are actually seeing as the past. Yes, you heard that right. You're actually seeing from the past. Like I don't know. Like how does the physics say that you can just see from the past? Okay, let me teach you now. Okay, now if you're like driving at the car, for like driving at the car, and this is you. You're driving at the car, and there's a person. Okay, this is the person. I don't know how to do it. And that's the person right over here. And they also run at the same, but there's a time dilation. That is, her time will be actually like normal, like it's 3 o'clock, but yours is a little bit slow, like might be. So you're going at the past, but but your person or your friend or somebody is going on the normal time. So this is how time dilation works, but this type of time dilation we can't even notice that. Being mighty of consequences, you should be near to that time. No, you should near the speed of light. You should be near. Like if this is the speed of light, and this is your new brand NASA ship, and that goes almost the speed of light, you can clearly see the time dilation. You can just clearly see that somebody's at the car, but that time will be somewhat like this. Like these two are different. I can't wait. Okay. Well, the best example for time dilation is actually black holes. Like you might say, what's time dilation? Some of you know and some of you don't know, but still I'll explain what's time dilation. It's the difference between of time. Like her time is 3 o'clock, but your time is like passed over that. That's called time dilation. It's not the world. Not like your friend is in Asia, in the country of India, and her time is like this. and you're in Canada, and the time dilation is not like this. This is actually somewhat correct, but wrong. I don't know. So time dilation is the difference between of the time. The best. Oh no. Okay, that's the best example for time dilation is actually black hole. Oh, my handwriting is terrible. Black hole. I think I can't even read that, but that's black hole. Okay. Actually, how old is a black hole? Just difference between in the time in the world and the black hole. How? Like it's just absorbing all of the things. Like it's just sucking like a vacuum cleaner. Well, yeah, but there's a time dilation. You know that Albert Einstein created the time waves. And this is the sun and this is the earth. Earth rotates or Earth orbits around the sun. Well, how does it orbit? Because of this bump. I don't know what's that. Well, it's a bump. That's how Albert Einstein did the bending of object. I don't know. But Albert Einstein, when he made that theory, so if a black hole came, it just dilates all of the time. So if you're going into it further and further, like you're the astronaut right here. I don't know if you know that an astronaut, but it's actually an astronaut right here. But the further you go near, the slower the time will be. Yes. But black holes often die with an white hole. As if they get older, they spit out. Well, if you get absorbed, that's it, because you need to wait Google here. That means it's just one with hundreds of zero. Hundreds of zeros. So, of the end of that Google years, so you will get out from the black hole because it will turn into a white hole. White hole is the opposite of that and just spit out everything. Like it's the opposite of a black hole. And there's another opposite called quasars. If you don't know that drawing, that's a quasar. It will be somewhat like this. It will change. It will mostly be blue, yellow, red. But why are we talking about quasars? Or this? What about this? Why? Because it also been the time. Like if you see farther and farther, the time will be go. And if you go nearer and nearer, the time can't be even noticeable. So that means or person near to us are all past? Are we seeing the past? Well, it's technically correct, but this I can't explain because you're almost seeing the future, but a little bit error because everything is past around you, but there's a minor second that changes, but actually minor millisecond that changes. So yeah, you see all of them as past, but it's just smallest change that you can't even see. That's just a millisecond. But if you see some farther suns, like black holes, like the farther black holes, like okay, unicorn, the nearest black hole. I'm not joking. Unicorn is a real black hole. It's 1040 light years away from us. So if you see that, if you see that, you're seeing the past. So that's how. Look, you're actually seeing all of them past. But the trick is, you're seeing the small changes, but you can't even see. You need to see like a built-in with not three but four